frequency case, your everything is basically in terms of voltage and current. So voltage and current are basically measurable quantity at very low frequency. Okay, but when you go to very high frequency, in those frequency you will not able to measure the voltage or current. Okay, so that in that case you will have electric field and magnetic field, and that is also true that electric field and magnetic field are also cannot be directly measured. Basically what you do, so basically you measure the power of the electromagnetic wave, and there are devices are there in the in practice, that is for example network analyzer. Network analyzer is one of the very important device for measuring electromagnetic wave and related phenomena. Okay, so basically using network analyzer, people basically measure the S parameter, and S parameter is also related to circuit domain. It is basically related to both circuit domain and also electromagnetics domain. Okay, so using this network analyzer and some there are other devices are also available. So we basically measure or basically you can say do experiment on electromagnetic. Okay. So let's start our discussion. So this is the introductory lecture. Okay, let me check. It has been uploaded. Okay, so all of you are familiar with me. So you have already attended one of the class, that is basically circuit theory or basically network theory. You have already attended, and you are another thing I would like to mention, that regarding the grade. So you know that question will be based on basically random question, and you will not get uniform question as long as it is online, and if it is offline then there will be uniform question, otherwise it will be random question for each student. So there will be some different question, and another thing is you have to study. Without study, if you think of copying, then in that case you will not able to pass or you will not able to get a good grade. Okay, if you are thinking that okay, I don't want to attend the lecture and I will just basically manage by myself by cheating or somehow. So I think that does not work, especially in my class. Okay, so what are the prerequisites for this course? Okay, so the course name is basically its code is basically E3004 electromagnetic field theory. So as you can understand that from the name, it is basically related to the electricity and magnetism. Okay. So what are the prerequisites? So because it is basically related to space and time. Okay, so as you know, the field is basically function of both space and time. Okay, so basically when you have a dynamic field which is basically changing with respect to time, and also it is basically changing with respect to space. Okay, so you are already familiar with wave, concept of wave. Are you familiar?
Yes, sir. Yes, sir.
Okay, so all of you are familiar with the concept of wave. Wave basically function of, you know, that both space and time. So as the things is basically that wave and field, so these are basically function of both space and time. So you need some background of vector and vector algebra and basically vector calculus also. Okay, so because the Maxwell equation are basically written in terms of vector calculus. Okay. So that's why you need some background on that. So we will cover up those preliminary background, and also I will revise some of the concepts which I have already discussed in your network theory class. Okay, so let's see what are the prerequisites. The first is basic electrical engineering. Obviously, you should cover that one. Then you should have network theory. You have already attended that class. Complex number. So I hope both all of you have completed that complex analysis course in maths.
Yes, sir.
Yes, sir.
Okay, so these are some of the link that you can go through those video, and you can there are some visual effect are there, so you will able to understand some of the concept. And then another concept is basically linear algebra, because here everything is basically linearly related, every quantity. So in the Maxwell equation, basically we will mainly solve the Maxwell equation or basically study the Maxwell equation in the linear system. Okay, so basically we study the Maxwell equation in the linear material. Linear material means here the electric field and magnetic field, or let's say electric field, electric flux density or electric field. So those are basically linearly related, not non-linear. Okay, so non-linear is very tough thing, and we will not cover that one. Okay, so that is not part of our course. Okay, so you need some basic knowledge of linear algebra. And why I am saying that linear algebra is very important, because nowadays most of you basically have to go to machine learning and those kind of industry. Okay, so for that linear algebra, so there is no substitute of linear algebra. Okay, so if you don't know linear algebra, then you will not able to do good coding. Okay, in machine learning also, if you want to do some research, or let's say some company job also in in that case, basically you need to have a good background in linear algebra. So linear algebra is one of the must required course in nowadays in modern, for modern engineer. Okay, so both the electrical engineering and other engineer also. Okay, and then another course you have already, I think, have done, that is basically differential equation. So because here the Maxwell equation are basically written in terms of differential equation, or basically you can say that vector differential equation. Okay, so that's why you need basically a background of little bit of background of differential equation. And another thing is required, basically vector calculus. Okay, so vector calculus, basically concept of gradient, what is gradient, what is physically mean by gradient, and basically what is divergence, what is the physical meaning of divergence, then curl. Okay, so this concept, and what is dot product, what is cross product, and their explanation, how basically those things work. So you need to have some knowledge on that. Okay, so these are some of the video link I have posted. So if you have time, I know all of you are but if you get some time, please go through this video material. I hope some of the concept will be more clear. So there are certain things that cannot be discussed in the class itself. Okay, so that's why these are some additional material. If you go through this material, then I hope you will get some knowledge and good understanding about the some of the concept. Okay, so next is, which textbook do you need to follow? Okay, so we will follow a single textbook. So not multiple textbook. This time we are not following multiple textbook. We are follow just only this single textbook. So that is basically Principle of Electromagnetics, 6th edition. The book is originally written by Matthew Eno Sadiku, and it was this is basically Indian edition of this, basically low price. Okay, so the original price of the book is basically you can say some some, let's say $1,000. Actually, I cannot say that how much is the exact cost, but it is a very costly book, that original version. Okay, or that main edition. So this is basically Indian edition, and it has been adapted by S.B. Kulkarni of IIT Bombay, and this is Professor Sadiku, and he actually mainly written this book, and this is one of the good book for the undergrad electromagnetic course. Now, I will also provide some online video lecture material. Okay. So this lecture material has been designed or prepared by Raymond Rumpf. Actually, he devoted a lots of time on preparing this kind of lecture, and so his lecture are very good. And one of the good thing is basically the visual effect. So to understand the electromagnetic, so you need to have some visualization of the electromagnetic wave or visual effect. So visual effect is very necessary, because otherwise it will sound like abstract and some mathematical equation. So it is very difficult to understand the mathematical equation at first. Okay, so you will gradually understand the equation and their meaning. But if you try to visualize that how the thing is going on, then you can remember that for a long time. Okay, so visual is always good compared to simple, you can say, the complex mathematical equation. Yeah. So this so we will not cover all the portion of this course. that is design. So we will mainly cover that review of vector calculus. So this portion will cover, then Maxwell equation. So what are the terms and things? Okay, so those things, how that Maxwell equation has been evolved. So those kind of things we will discuss. Then we will discuss about the simple that electrostatic. Although we are already a little bit familiar with electrostatic, but still for the continuity of the course and for in-depth understanding of the electrostatic, we will discuss about the electrostatic from this course material, or you can go through this course material also. Then we will discuss about the magnetostatic. Okay, so how this static magnetic field are formed and from the basically flow of current. Okay, flow of current or basically movement of charge. Okay, so basically charge create electrostatic field. So if you have a standing charge, it will create a electric field surround that. So that is basically static. Okay, so that is not dynamic. It is not varying with respect to time. Then as the charge move, okay, so as the charge move, then it will create some magnetic field. Okay, so that is also static, because that velocity, if we consider that velocity is not changing with respect to time, so in that case it is also static. Okay, because movement means constant movement of basically electron. Okay, constant movement of electron basically, or basically charge particle basically create magnetic field, and as long as the velocity is constant, then the field is static. It is not varying with respect to time. So if something is varying with respect to time is basically dynamic, and which is not varying with respect to time is basically static. Then we will talk about the electromagnetic wave. So electromagnetic wave is basically here the dynamics is coming. So in the electromagnetic wave, so the dynamics is coming when that charge particle is moving in a accelerating and or deaccelerating velocity. So in that case it will create electromagnetic wave, because there are actually two kind of phenomena is occurring, that electric field, the change in electric field basically produce some magnetic field, and change in magnetic field, that due to the dynamics of that the system, so change in magnetic field will produce electric field. So this phenomena repeat, and in that way basically electromagnetic wave propagates, and we will discuss this in more details later on. Then we will discuss about the wave scattering. So how the electromagnetic wave incident on a particular surface or basically particular material, and how it get reflect back, and some of the portion get basically transmitted into the medium. Okay, so those kind of phenomena we will basically discuss. Okay, so here scattering means basically two kind of phenomena is occurring. In scattering, one is transmission, another is reflection. Incident, transmission and reflection. So that's why the term scattering is coming, and we will discuss later on about the scattering parameter also. So that I was supposed to discuss in the network theory class itself, but due to lack of time we were not able to cover that part. Okay, so scattering parameter is one of the very important concept as an electrical engineer. Okay, because scattering parameter is one of the measurable quantity at very high frequency. Okay, so when let us say you want to study about the electromagnetic effect of let us say motor. Okay, so in the motor if sometime due to non-linearity or maybe due to some other effects of high frequency sometimes generated. So that high frequency sometimes get radiated back, and that effect another let us say another element, so that nearby, so those kind of phenomena can be explained from the electromagnetic point of view. Okay, so that's why that concept of scattering parameter is one of the very important concept. Next we will talk about the transmission line. So when we come to transmission line, again you are basically coming to circuit theory. So up to this point is basically electromagnetics, but when we come to transmission line, because the transmission line are basically one of the block that basically link is the circuit theory concept and the electromagnetic concept. Okay, so the transmission line are basically the circuit theoretic element. Okay, so it is the how the voltage or current or the field inside the transmission line can be easily explained from both circuit theoretic point of view and from the electromagnetic point of view. Okay, so that's why it is one of the, you can say it is the linking element. Okay, so the transmission line is basically linking element of circuit theory and electromagnetic field theory. Okay, so waveguide I will not discuss because lack of time, and then we may discuss about the Smith chart or impedance matching. So that's it. So this the computational electromagnetics. So these two we will not discuss. Okay. Okay, so this is the tentative course. Okay, so at first review of vector calculus, then electrostatic, then magnetostatic, and then electromagnetic wave, EM wave scattering, transmission line, and impedance matching. Okay, so these are the following topic we will try to cover in this course. Okay. Okay, so I need one suggestion from you, that is basically whether we should start from electromagnetics and then go into transmission line and in that way, or we can start transmission line separately, then we can gradually in the let us say later half of this course we can start the electromagnetics, because you have already background of circuit theory. So it is not difficult to understand the transmission line theory. Okay. So what is your point of view?
Sir, the first option.
Yes, sir.
The transmission line theory.
Electromagnetic first.
Electromagnetic first.
Yes, sir.
Yes.
Okay. That's good. Okay, so we start from basic of vector calculus, then electrostatic, electromagnetic, magnetostatic, electromagnetic, and then EM scattering, and then move to transmission line and impedance matching. Okay, and mainly basically the practical problem or real life things. So these are basically related to electromagnetic, basically transmission line and impedance matching related problem. Okay. And this kind of you can say how can I say, so this kind of means advanced level you can say calculation of the electromagnetic wave and their scattering are basically done through computational electromagnetic tool. So you not actually you don't need to be familiar with those computational electromagnetic tool, because mainly those who do PG on let us say electromagnetic related course, so they need to know, but you should aware that basically this advanced level computation of you can say electromagnetic phenomena or whatever the scattering or incident or whatever the phenomena, so those are basically done through computational electromagnetic tool. So for example, some of you are maybe familiar with you can say that ANSYS software. Okay, so ANSYS software, so they basically provide some solution for, let's say for example HFSS is one of the software, or let's say for the circuit simulator or circuit related software like ADS, okay, ADS pathway. So those are some kind of software commercially available. So they basically take care of this part. Okay, so you just only need to understand the physics, but actually you will not practically do this thing. Okay, as long as you are not doing some research on this topic or something. Okay, basically main means practical problems solving are basically done through software only. Okay, so here you can do by yourself. So this problem you can do it by yourself, but this kind of problem in advanced level are basically done by software itself. Okay. Okay, so we are talking about electromagnetics. Okay, so what is electromagnetics? So that is one of the question, that what is electromagnetics? Electromagnetics is basically a branch of physics involving the study of electromagnetic force, a type of physical interaction that occur between electric charge particle. So here I am talking about only electric charge particle, I am not talking about the magnetics. Okay, so here I am talking about electric charge particle. Electric charge particle basically produce electric field. But why electromagnetics? Why electromagnetics? Why this term electromagnetics is coming? Okay, because it is basically related to both electricity and magnetism. It is basically related to both electricity and magnetism. So you have already understand maybe in your physics 1 or physics 2 course that basically the charge particle when it's moved, it produces the magnetic field also. Okay, so that's why that electricity and magnetism are not separate phenomena, they are basically interrelated phenomena. Okay. Now why electromagnetics? Why this term electromagnetics is coming? So the electromagnetic force is carried by electromagnetic field composed of electric field and magnetic field. So because it is related to that electromagnetic field or force is basically related to the both electric field and magnetic field, and it is responsible for electromagnetic radiation such as light. Okay, so the light is basically electromagnetic wave or electromagnetic radiation. Then that why this, that how this electromagnetic force, okay, how this electromagnetic force and the other force. So what are the basically you can say that what is electromagnetic force? Electromagnetics is one of the four fundamental interaction or commonly referred as force. Okay, so one of the fundamental force in nature, that is basically electromagnetic force, gravitational force, weak nuclear force and strong nuclear force. So this is one of them. Electromagnetic force is basically one of them, or electromagnetic interaction is one of them in nature. Okay, so that's why it is basically one of the important thing, and basically mostly this branch of electromagnetics basically evolved in physics only. Okay, so but it has very good means basically engineering application. So that's why we are studying this course. Okay. Okay. Let's see that what we will call as electromagnetic phenomena and what not. Okay. So one of the electromagnetic phenomena is radio wave. Okay. So you know that a telephone tower is there, and from the telephone tower electromagnetic wave is coming to your cell phone, and that's why you are able to talk to your phone and talk to your friend through the phone. Okay. And another application, let's say microwave oven. Okay, so it is basically used for heating purpose. Okay. So this is basically used for heating purpose. So this is one kind of application of electromagnetic wave, and then another is basically application you can say that is basically radio telescopy. So some of you may be familiar that there in India there is a very big and large radio telescope center is there, and using this telescope they basically try to observe that certain phenomena which are not possible using that visible light. So using the visible light telescope you cannot able to detect all the phenomena happening in the inverse. Sometimes we need a radio telescope. Okay, so this is another application, and also you can say the satellite link. Okay, so the satellite link is basically formed through radio wave or basically microwave. Okay, and then it's come through the charge. Okay, charge is basically electrostatic. Okay, so simple, if you have a charge stored in a let's say a particular surface, then you know what happens. Basically, charge try to attract each other, and that's why that you know that electrostatic charge. So now is basically winter. So in the winter, you basically observe the phenomena of electrostatic charge when basically you open your sweater or something, that you know that some small noise is there, na? Small kind of that but some noise is there. So that is basically due to electrostatic charge. Okay. And then it's come to magnetostatics, the simple permanent magnet. Okay, so this is also related to the electromagnetic phenomena, and you know that in permanent magnet basically magnetic field basically occur, and this is basically related to electromagnetics. And then it comes to light. So light is one of the important electromagnetic wave, and without light we cannot do lots of things basically. Okay. And then it comes to X-ray. X-ray is also electromagnetic wave. So these are basically example of some of the electromagnetic wave and their application. So please note that this slide has been taken from Ram's lecture. Okay, so I have not prepared this slide. Okay. And then what are not electromagnetic? Okay. So one is sound wave. Sound wave is not electromagnetic, or gravity or gravitational wave is not electromagnetic wave. Okay. And vibration, so basically mechanical vibration of a particle that creates basically acoustic wave. Okay, and that is also not related to electromagnetic wave. Okay, so these are wave but not electromagnetic. Okay, so let's come to Maxwell equation. So our everything is basically based on Maxwell equation. Okay, let's move to the next slide. Okay, so these are the 4 equations. Okay. These are the 4 equations. Actually, Maxwell did not propose all these 4 equations. Okay. So actually, what he did, he basically interrelated. He interrelated this equation. Okay, what he did, he basically interrelated this equation such that electricity and magnetism, these are not different phenomena, and he first time predicted that light is basically electromagnetic wave. Okay, so that is basically his contribution. So the first law is basically Gauss law. So it basically states, so this is a kind of equation. It is basically little bit difficult to understand at a glance. Okay, but I'll try to simplify by some word, and if you go through some lecture, let's say by Professor Rumpf, then you can visualize some of the effect. Okay, how that Gauss law, what is physically described, and those kind of effect. Okay. Okay, so it has 2 form. One is basically differential form, another is basically integral form. So it's basically state that if you have a charged particle, in a closed surface, then the total flux going out or going in into the that's closed surface is basically equals to the charge stored inside that closed surface. That closed surface is sometimes called the Gaussian surface. Okay. Then it comes to Gauss law for magnetism. Although this Gauss law for magnetism, it is not clear that whether the Gauss first time proposed this one or someone else. Okay, so that's why sometimes it is not called as Gauss law. Okay, so it is basically analogous to Gauss law of electricity. So that's why sometimes we call it is Gauss law for magnetism. So it states that if you have a closed surface, then the total magnetic flux, enclosed by the surface is basically equals to 0. So whatever the flux is going out, so that must come in. So let's describe it. So let's say you have a magnet. Na? Let's say you have a magnet, north pole and south pole. So from the north pole, your magnetic field will come out. Sorry. Will come out and go so south. Occur here also. It will come out from north and go into south. So this way. Okay. So you have lots of flux are there. So flux are basically imaginary path. Okay. So now if you draw any closed surface, let's say you draw this surface. So let's say you draw this surface. Okay. So you can see that 2 flux is coming in and 2 flux is going out. So net flux, the net flux crossing this surface, arbitrary surface, let's say it is a spherical surface. Okay. Arbitrary surface is basically 0. Always, it is always true. Why it is true?
Sir, because magnetic monopole does not exist.
Yes, because magnetic monopole does not exist. Okay, so it should have. So if you cut the magnet small piece, you will never get a monopole. Why monopole does not exist? Because what is the fundamental cause of magnetism? What is the fundamental cause of magnetism? It is basically rotation of electron. So the fundamental cause of magnetism is basically rotation of electron. Okay, so as the electron rotate, let's say E minus, as the electron rotate around a let's say around its nucleus. Okay, so that basically produce a magnetic moment. Okay, so that basically produce magnetic moment, and you can see that this magnetic moment. So one side we basically consider as north pole and another side is considered the south pole. Okay, so the magnetism, the fundamental phenomena of magnetism occur due to spin of electron. Okay, so that's why it will always have a north pole and south pole. Okay, so you will never have magnetic monopole. Okay, so what about the next two law? So that is basically Maxwell Faraday equation. Okay, so originally this equation was proposed by Michael Faraday, and later on it was little bit you can say that that mathematical. Okay, so that mathematical form was given by Maxwell. Okay, so originally that Faraday basically discovered this, and Maxwell basically written it in a mathematical form. So it basically state that change in magnetic field. So change in magnetic field will produce electric field. Change in magnetic field will produce electromagnetic field or electrical potential. Okay, so the change in magnetic field will leads to electrical potential. So you are already familiar with this. Okay, so the change in magnetic fields, and you have utilized this in your many electrical machine device. Okay, and then next is basically Ampere Circuited Law. Okay, so Ampere Circuited Law. So originally what Ampere proposed, that if you have a current element, so if you have a current element means basically movement of electron. So current element means what is current? Current is basically movement of electron. So if you have a current element, then you will have a magnetic field surround it. Okay, so it is basically based on this right hand rule. Okay, so so you can see that if you have a current element, then that will basically produce a magnetic field. Okay, so basically this magnetic field is basically static in nature. So this magnetic field is basically, if you have a constant current, okay, the velocity of the current is time invariant. Okay, so the velocity of the current or the current is basically time invariant. Okay, so IT is basically some constant. Okay, then in that case this magnetic field is also constant. So magnetic field B is also for the function of time is basically some constant B naught, I naught. Okay, so it is basically constant. So what is the addition of Maxwell is basically this term, that del E del T, or sometimes we call del D del T. Okay, so this del D del T is the addition of Maxwell. Okay, so why he did? Because one of the mathematical property that divergence of curl should be 0. The divergence of curl should be 0. Okay, so that property was not satisfied with this equation with only J. So then what he did, he basically include this term, okay, epsilon into del E del T. So it is sometimes called del D del T. Okay, so del D del T, this term he included in the equation and make the complete Maxwell equation. And another thing I would like to mention, that here you can see, so this equation and this equation has some similarity. So you have, it has del B del T, and here you have del D del T. Okay. Now these two equation has here it has some similarity, but this term is missing, that current. Okay, J is basically surface current density. So that J is basically missing. Sometime in solving this kind of Maxwell equation, we basically sometimes we include M also. So that is basically magnetic current. So this is only for the mathematical purpose. Sometimes we write that del cross E. So del cross E is equals to minus del B del T minus M, where M is basically magnetic current. Okay, so and it is useful in solving certain kind of electromagnetic problem. Okay, but it does not exist. It does not exist, but still in the for the mathematical calculation we can use it. Okay, for mathematical calculation we can use it, but it does not exist. Okay, so please note that. Okay, so so we discuss about, okay, so I did not complete this slide. Okay, so you can understand, so who are the contributor of this Maxwell equation? So first is basically Gauss, then basically Faraday, Ampere, Maxwell and Coulomb. Okay, so these are the 4 people mainly main contributor of this Maxwell equation. Okay, so actually Maxwell did not invent all the equation, but other invented, and Maxwell basically clumped them together and formed the equation which can describe all kind of electromagnetic phenomena, from whatever that whatever you have studied in machine, or let us say some radio frequency, or let us say for example wireless power transfer or transformer. Okay, so all the phenomena can be explained from the this 4 magical equation. Okay. So, so that's it for today. I will not continue much, and in the next class we basically start the vector calculus, because it will take some time to start the vector calculus. Okay, and before that I am just requesting you, please go through some of the you can say this lecture material. Okay, so that you will have some background and you can easily understand those kind of concepts. Okay. Okay, so that's it for today, and do you have any question or query, you may ask.
Sir, why at higher frequencies current and voltage cannot be measured?
Okay, good question. So why at very high frequency current and voltage cannot be measured? Okay, so one of the thing is basically it can be measured. I am not saying that exactly cannot be measured, but the cost of the device is very high. Okay, so for example, you cannot measure the voltage of light. Can you measure? Do you have ever seen that voltage of light? Do you have able to measure? So it is not possible. Okay. So the main reason is basically the limitation. The limitation is why it is limited, because of this phenomenon. Actually, you can see that. Let's see. So you can see, so there are lots of reasons. Okay, so this is not one of the reasons. So I will explain one by one. So one of the things that you can see that as the frequency increase, so this basically you can say this time period of the signal is basically very narrow. Okay, so it is basically very you can say with very small amount of time, it is basically fluctuates in a very you can say very quickly. Okay, so it is basically fluctuate in a very quick way. Okay. So that is one of the reason, and another reason is basically you can say that you will not always have 2 wires. So for example, let us say you have a waveguide. Waveguide is one of the device which basically carry electromagnetic wave. So in waveguide, so to measure the voltage or current, you need basically 2 wires. So here you have only one conductor. So one conductor is carrying the electromagnetic wave. So you cannot have a basically two conductor system. So you cannot able to measure. Okay, so for to measure the voltage, you need at least two point. Na? You need 2 terminal. Without 2 terminal, you cannot basically measure the basically voltage. Okay, so you may argue that you may able to measure, let's say with some ground potential. You can create a universal ground, and then with respect to that. So in that case also, you will not exactly able to measure the voltage. And another reason is basically it is function of space. It is that a very high frequency signal is basically function of space. For example, let's say you have a transmission line. Okay, so what you have studied in circuit theory, that whatever the voltage here, let's say V1, the same voltage will appear here. Okay, but in case of transmission line, when it is basically, you can say in terms of lambda, let's say it is basically you can say let's say half lambda or 1 lambda. Okay, so it is half lambda, 1 lambda. So in that case, here whatever the potential, that is, let's say some V1, here the potential may be V2. Okay, because it is space, function of space also. So that's why we cannot actually able to measure the voltage or current at very high frequency. Okay. So there are certain problems are there. Okay. Any other question? Okay. So then I'm basically closing this class. Okay. And in the next class we will discuss about the vector algebra and vector calculus. Okay. Okay. So goodbye for now. See you in the next class.
Thank you, sir.
Okay, you are welcome.